Okay. Good afternoon, everyone. I am Ram Kumar. I am a senior developer in this organization. I have 15 years experience in the full stack development. So I came as a emergency coordinator now. So before starting today's topic, do you have any questions in the previous topics kind of thing? I'll wait for a minute. So because as I said, I have 15 years experience, I could explain in some other way and I could clear some of your questions. Or let me do one thing. Let me start the session. If you have any questions or you remind any questions, you can ask me later. Okay. I'm sharing my screen. So today's topic, I will start with how to start a SQL query and what is the order of execution, those things. My screen visible?
Yes, sir.
Okay, thanks. So as you know, you have come across so many keywords. So any query will look like select. So this is about select queries. So select your columns list and the main table, the from table. I call it table one. And later you can do any number of inner joins. Secondary joins. You can do any number of joins. Inner, left. Later you could do right join, self join. Self joins are nothing but inner, left, right. Same table getting joined with your requirement, like inner, left, right, anything. I will complete one of this line with proper syntax. Table 2 on table 1 dot some column name equal to table 2 dot its column name. Maybe C2 in this table, C1 in that table. Likewise, you have to complete the other joins. Then your filter will come. Whatever happened here from joins, where will get applied to those tables. Actually, once the query starts, this from table, this whole table will get stored in the memory. Then it will do join with the second table. Then the third join, second join, third join, then the fourth join. Everything will go into the memory and the filter will happen, row-wise filter will happen in the where condition. Later, you can do group. Whatever there in the memory, the group by will get work. Then in the grouping, you can do filter using having. Then you can order the query output in ascending or descending. Then you can do pagination. Pagination, I'm not sure it is covered. So you can say offset some numbers and limit some numbers. Offset means you have to move the results, like my select from the joins where condition group by having order by. Once all these get executed in the CPU or in the Postgres memory or something, Consider you have some 10 records. And I say offset 0. That means start with, don't do any offset. That means start with the first row. If I say offset 2 in the output, it will ignore the first two records. And you will get result from third row. And I say limit 5. That means 1, 2, 3, 4, 5. The rest, whatever there, will be removed. So you will get only the 5 records, removing the first 2 records. So this is the order of execution. Once you are done with this, you can do the selects, whatever column you need in the output. If you don't want any columns, you better not include it here, because uh, this output will travel through the network from the database to your application server or your program through the internet, and that will be processed and transferred to your browsers. The day-to-day life, whatever you see, if you open your Gmail, you will see only the first 50 email came to you in the inbox. If you go to sent item, you will see the first 50. Okay, that is working like this only. If you send everything, it will choke the network, it will uh, freeze your browser. So this is important one. So even in the column, you don't add unnecessary things. That will also do the same thing. It will increase the network bandwidth, amount of data to be transferred, everything. Okay. So this is the order of execution. This is how you cannot change the order. Like you cannot put group by after from. You cannot put having before group by. You cannot put order by before having. But one thing you can do, offset limit you can swap. That is not an issue. So this is the order of query writing or execution. The backend process will do like this only. How can I know that query is following this order in this in its execution? Execution in the sense, all these things are written in C or some language that will get executed, right? So that is what I'm calling execution. All these things has to be done. You can do one thing like put explain and your query. Postgres will tell you how it is going to execute it. So let me open one Postgres. So this is one Postgres prompt. So I have INVM master. Hope this is some familiar table for you. So I am going to say select start from INV master. So I am going to put explain. It says sequence scan on INVM master. Sequence scan. That means it will go into the table one by one row. I put one where condition. Where env id equal to 100, and I give explain. Says index scan using INVM master P key, that is primary key. So in the design you can see what is that key name. That means index search is happening. I will tell you the difference between sequence scan and index scan. Sequence scan means it will go through each and every row. So we have INVM master here in the CSV format. So we have around 1244 row. Sequence scan means Postgres will look into first row, and then second row, and then third row, and then fourth row. It will process the queries one by one row. Instead, index scan means it will do index search on the told column, and it will retrieve the results faster. So index is nothing but some algorithms implemented in the C language. Postgres is developed over C. So we have some B tree and other stuffs. So it will use those algorithms and retrieve the records faster. And you can see the cost. Cost is nothing but the memory utilization, hardware utilization, that means CPU utilization, everything put together, they will say cost. And it will come across 1244 rows. So I told you that CSV had some 1200 rows. It will go through all the records. But here you can see the cost is less compared to the sequence scan. It is just 8.29. This is 18.14. Actually, there are only 1,000 records. In day-to-day life, if you go to any production server, you will see 1 million. That means 10 lakh, 1 crore records. There you can see much cost difference. It will be in 7 digits. If you use the proper scanning, proper indexing, you will see only 3 digits. So it will go through only one record. The CPU will do the process over only one record. But here CPU will do the process over 1,244 records. So this is how it's going to work. Let me put one join and see how the CPU works. You can write the query in a multi-line, single line, anywhere, any kind of thing. But I prefer to start with select and your columns with some indentation. That means extra space, empty blank space. Then do the from, inner join, everything in a new line. So that in the future, you can debug the queries easily. Maybe the query was written by you long back or by someone else. Once you come into the corporate means IT department, you will not be working on your own code only. You have to work on some other's code. He could be in some other team and doing some other project, so you have to take care of his coding also. So in that time, if he if that person followed this thing, it will be easier for you. If you follow this thing, that will be easy for your followers. So I prefer to go with this indentation, like each keyword starts in a new line. So right now I put select and I say from. I'm not filling any columns because that is not mandate for me now for this example. I say analyze master with analyze name, and I do inner join. Let me see what are the tables available. Invoice table is there. INV ID is so this INV ID is referred in INV details table. So let me take that one as the join table. Say invoice details. ID. Let me put star. I am giving explain. This is the plan how the CPU will do the process. So it will do a sequence scan because I didn't do any filter, so it has to go through all the lines. All the rows in the INVM master should get joined with INV details. So that sequence scan will go through this line, and a hash filtering and a sequence scan on INVM details, and these two will get some joint hash condition and get joined. So this is how the CPU will do the process. Consider you get some issues like query is taking so much time, even though you have some filters and it's not working. Let me put an example. So I have a where condition, im dot aid. I'm casting this to a text and I'm looking for ending with 5. So it is doing a sequence scan and the INV master with a filter INV underscore ID. I'm casting it to a text and checking for the numbers ending with 5. That means divisible by 5 or something. Some concept we are applying and randomly getting it. So the people can say INV ID is the primary key. That means by default it will have the index. So this is the design INV master. It has INV ID. That is the primary key. That means it is a index. So it should work faster. But your planner, your plan, CPU plan is not having the hash scan or index scan. Yeah, it is going through sequence scan. That means it will go through all the records. Instead, what I have to do is, what I require is the 5, 10, oh sorry, 5, 15, 25, like this I need. For each 10 records, I am getting one record, but it will go through all the 1200 records. I need only 120 records. This is happening because a casting is happening over the index field. So it is going through a sequence scan. So I am making this, removing this casting, and I say some formula I am applying, and I am giving this to the CPU. So here also some formula is getting applied. So still sequence scan is coming. Okay. Say like 10, 15, 35. This is just an example. So now it is using an index scan. So that means with some change, your query will work faster. That time I told you to compare the cost. Actually, with lesser row, the query is not bringing up much faster. From 428, it has come for 420 only. But look at this row. Instead of processing through 99 records, it is using only 66 records. So in this way, you can see with the help of explain, you can see how the CPU will do the process. So what we started is order of execution. It will start with from, joins, where, group by, having, order by column name, ascending or descending. Then offset limit. With this planner, you can see it with explain keyword. Any questions over this? I see one raised hand. So now we have seen what is the order of execution and how can we verify it with the explain keyword. Next, what we can see is transactions. So in general, if you come for a web service or a computation, any computation, you can see multi-user. Uh, Google will have some database. You will do the database search, so it will go to one particular table. Same time, some other guys will be doing the same search. So same table will be used by multiple people. Same time, their engine could do some change in the algorithm and bring some outputs. So they will also do some inserts, right? Take some cricket scoreboard as your table. When the match is going, everyone will be viewing the scoreboard. That means all are doing select queries, but one guy will be doing the insert. So insert is happening. That insert could be done by many people, and select will be used by so many people. So what will happen if two guys are doing insert at the same time, or one guy is doing insert, another guy is doing update? What will happen to the select? That is what coming as transactions. uh, whenever you do, whenever you start query for insert, update, delete, truncate, anything you do in transaction mode, that is a safer thing. In transaction, you can start the transaction. Whenever required, you can save it at that point. That we called save as save point. Whenever you don't want changes into the data table, you can do rollback. Actually, start is nothing but begin. You can start the transaction, save it with save points, and if you don't want, do rollback. If you don't want any changes until that save point, you can do rollback to that save point. Save point, you can say uh, updated total score. Otherwise, if you don't want this rollback, will undo all the changes done after the save point. If you do general rollback, that will undo all the changes done after the begin. So in case if you don't want to do any rollback, you can say commit or end. Semicolon is must in the end of all these lines. Let me put an example. I say begin. So you can see a star here. That means previously you will not see stars in the prompt. You can see minus. That means a query started and it is waiting for the query to get end with a semicolon. Likewise, you can see a star. If you put a select, it will become minus. So I have to put a semicolon. Star means you are into a role transaction mode. This is available after Postgres 13 or 14. I say select star from master where I get some data. So I am updating the date in this data. Update the master set. This is important. This transaction part is important before you go through update, begin, delete anything. Just I will go through the queries. You will learn these things in detail if it is not already covered. I will say one where. If you don't put the where, it will update all the records. NVID equal to. So just consider I didn't put where. Will say updated 1244. That means it updated all the record with the same date. That is a mistake. It will cost uh, a black mark in your job if you are unable to recover the data. Even your customers will chew you. So your good thing you are in a transaction, so you can say rollback. Let me check what is there for the star records. It is still in the older date. That is 2020. Actually, I put as 2023. Let me see what happened to the second record. It's still in the 2020. So goodness, I saved my job. I will get my salary this time. So again, what the mistake I did was I updated for all records. Instead, I have to do correctly this time. So I say where id id equal to 1, and I see updated one record. So last time I saw 1244. Now I see only one. So that means my update is correct. I can check the second record that is still in the 2020 November 1. So that means my query worked correctly. So I can say save point update 1. So I save point have. Now I say, for example, I'm doing the same mistake. 1244. So I have done a mistake. This mistake is artificial for now. So I have to recover back to the previous state. I have a save point which has an update. So I can do rollback. Before that, let me check what is the records. So second record is having 2023 January 1. So I say rollback to this name. Now I see the second record. It has come 2020. So that means database has undo everything. So in Notepad we have undo, redo everything, right? So that is what this begin, save point, rollback. everything. So I'm still in the transaction mode. Uh, so with my memory, I can say I updated the date in the first record. So if I do roll back, it will undo everything. That means this is the only change done in the database right now. If it is fine, I can say commit or end. Either way I can do. I say commit, says commit. That means it is into the table. For safety, I am checking the second record. It is still in the 2020. And I am checking the first record. It is now 2023 January 1. This is what I updated. Uh, what happens if I do a syntax error in the begin and everything? I say begin. I have the update query. And I do a spelling mistake. Select is having a spelling mistake. Okay, what will happen? I put the right query. It will say current transaction is aborted because some error happened. So what Postgres is thinking, we tried to do something, but it didn't work properly. If I try to do next query, uh, the logic could go wrong, whatever we thought. So he has changed it to exclamatory. That means hereafter we could not execute any query. This will say current transaction is aborted only. So we have to do end. End is common for both commit and rollback. If all your transaction worked properly, end will do commit. Otherwise, end will do rollback. You have to do rollback and then start the transaction again. So this is the negative scenario. The main interesting part in the transaction, I say begin and I see the first record. It is 2023. So this is one user and I open another one, a second user. Here also I am seeing the same, trying to see the same record. Into a different database. I have to change it. I see the record. So I'm into a transaction mode and I do an update here. Let me update this to current date. Current date is a keyword which will give you the current date. Oops, I updated wrongly to all the records. I do a rollback. Again, I do the begin. Equal to 1. It updated only one record. So let me put what is that? Keywords I used to do in the capital letter. In that case, I can debug the queries easily. So it will current date. It will print you the current date alone. If you say now, it will print you date and time. You can see the difference. It has time including millisecond and micro or macrosecond. This is milliseconds, first three digits. Then you have macro or milli, whatever it is. So you have 6 decimal in the seconds. Okay, let in this other user, date is changed. What if he tries to access the record? You can see it is still in the 2023. It is not yet changed, but My query updated the record, fine. Because as you are in the transaction, this is a separate page for you. You are running into a separate, if you are Hollywood movie lovers, you can see the timeline in the recent movies. So you are like in a separate timeline. You can see the records. If you are in a begin and did the update, only you can see this. For me, INVM okay. Last time I updated wrongly and rolled back. So I say current date and NVID equal to 1. Now I see the current record. It is 3rd 2023 March 22. In the other user I see it. Still he's in January 1. So this is the transaction. You are into a separate um, snapshot. So the changes will not reflect into the main database. Only you can see it. If you close the laptop or your server network get disconnected, everything will get rolled back. That time, even if you log in again, you will see the same 2023 January 1, not the updated record. This will reflect to all others once you complete the transaction properly. I say commit. Now let me say end. It's commit. No error happened, so it is committing the transaction. If I put in for some after some error, it will say rollback. So now I come to the next user. I ask the record. It says March 22. Previously, until I commit the transaction, it is January 1. So I have committed. Okay. So interestingly, it didn't reflect to others until I commit the transaction. So this is the usage of transaction mode. You can do any mistake and roll back it. And it will not reflect to others until you commit it. Okay, this is how the transaction works. Transaction can be used like in other ways, like there are some dependency tables, like 3 tables depending upon each other. I insert one record in one table and update other table with respect to this record. And in third table, I put an entry with respect to the whole operation. So consider you have a tally kind of thing. It will go through so many operations. Consider the 2 queries worked fine and the third didn't do. So you have to think back what has to be done. Everything has to be redone again. Instead, if you are in a transaction mode, when the first query and second query worked properly and the third query didn't, then it will you can do a rollback and you can start the operation as far from the first. So in many updates inserts are there in your process, you have to go through the transaction mode. Okay. So SQL, I am writing all the queries here in the prompt, but I am giving you quick info, Gmail search as a Google search, Gmail inbox as the examples. That means these queries has to be part of some other language that will execute the query and give the outputs. This prompt is not at all the permanent thing. Once you put it into some other language, that language will handle all the queries. Here you cannot expect, and that will be executed by 1 lakh people. Consider your railway booking. I'm not sure how many experience the Tatkal booking. Tatkal means previous day you can book for if you want a ticket before Deepavali day. Uh, so Deepavali is on some 20th. I want to travel on 19th night. So before that day, on 18th, I can book the ticket. That is called Tatkal in the railway system. It will open by 10 a.m. That particular time, you can see almost 1 crore or something requests come to the server. All the things will do these many queries, more select queries, and it will insert your records if you have done the booking, and it will update the booking details like this seat number is already booked by this guy. So many queries will run. All these things will go through some language like Java, Node, .NET, Python. Some language will handle this. Not all the time the SQL prompt is the place for you. You can write the query. Once you get the output properly, you can move this query into that particular language, then that will take care of the things. So in those cases, you cannot expect the first query worked properly, second query worked properly. I have to fix the third query. Likewise, you cannot do anything. You have to roll back that whole transaction so that some other people can come and book the ticket. Consider for one guy, you have booked the ticket, you have blocked the seat, but you didn't insert his payment details. Will come to the train and the TTRs will say, hey, you didn't pay for the train, and he will start fighting, right? Instead, you roll back the transaction, so his booking will get cancelled. He has to retry it again. That is what the advantage of this transaction mode. You don't have to put the things in a partial way, right? In other case, uh, you can do the inserts, you can book the ticket, you can say this ticket is already booked by some guy, but the payment failed. In that case, TTR will not know he didn't pay it. In those cases also, you can do a rollback. So he has to try the booking again from the start. So you have to say, I did the insert in this table, insert in this table, but the insert into that table is not working. Didn't work, so I will do insert manually. Though that cannot be done when 1 crore records are coming into the picture. You cannot type each and everything manually, right? So those places, this transaction is very useful. Any questions here? Because I'm going to further in this transaction. I hope you understand the transactions. So this is to safeguard your records from wrong inserts, wrong updates, wrong delete. You can roll back at any time. And in practical, when you put the queries into the language, the rollback is useful to undo everything in the process, and the customer has to redo the things. I hope this is fine for you. Let me jump one more step further in the transaction. So I am executing the same thing. I said begin. I update the same record. Consider the other guy is also doing the same. He's into a transaction and he's also updating the same record. Name master. Let me copy paste the query. So this is updated for me. If I do the commit, the other user can see it. But what if he also updates it? Any guesses? Uh, there I updated as current date. Here I say current date plus 1 day. 1 day has to be casted to time. Any guess what will happen if that guy do commit or this guy do commit? Okay, he has done the update already. So this guy is doing an update. The prompt is still blinking. I didn't get any output. This is called lock. That particular record is locked by the Postgres. It will not allow the other user to update and bring a confusion. Okay. Once I do a rollback or commit in this transaction, this guy will get updated. Let me do rollback. Let me give you one example. With a wrong query, syntax error is coming. So you have come to an exclamation tree. That means you have to roll back. Some error happened, you have to do rollback. Let me put end. Already I shown you for end commit came. This time if I do end, rollback will come because an error happened. So let me go to the other user. His update got completed, right? Postgres is not allowing the confusions. So this guy's transaction is completed. So this guy's transaction is getting updated. Likewise, you can come up to a deadlock. uh, so this guy is updating something. Let me close this transaction. Let me start and update the second record. Second record with current date +1. Here I start a transaction, update the first record. Right? Both of the guys are having the prompt safely. So I'm bringing you back the same situation. I put invoice ID 1 update, which was handled already by the other user. So my prompt is blinking. That means it is waiting for someone else to close the transaction. Here, he's fine. And I am updating the second record. Second record was already updated by the other guy, right? So technically what should happen? He should wait for the other guy, second user to get complete. Here, he should wait for the first guy to get complete. So this is called deadlock situation. Postgres is worth for detecting the deadlock and canceling one particular transaction. In this case, this is the second transaction. So he got a deadlock and he thrown an error. So right now you can do only rollback. If you complete the transaction, it is a rollback. Here, he was waiting for the other guy to complete. For him, logically the error happened, so the only way is to do rollback. So here for him, the update happened. So this is the lock and deadlock. Lock will wait for other guy to close the transaction. Deadlock will close the transaction automatically. So this we cannot say. So he's waiting for some other user. That means user two. User two is waiting for user one. In the demo, I can explain you user one is waiting for user two. But in the real time, when 1 lakh people accessing your application, you could not say that guy has to close the transaction, so this guy will come back, right? In those ways, in those situation, Postgres will do the deadlock and close one transaction. That is the second one, right? Begin started first for this guy, but this particular update came second. So in that case, he rolled back this transaction. So for him, the transaction got updated, right? This is the deadlock situation. First lock, then the deadlock. Any questions here? So it's been already 50 minutes up. We started by 2:35. So what we saw is order of execution, order of syntax you have to follow like this. If you follow in the new lines, the debugging will be easier. And I explained you how the explain works. It will show you how the Postgres will do the planning and execute it. And we saw transaction. So you have to start with the begin. You can save it anytime. Any number of save points you can create. Or you, I don't know what is the limit, how many save points we can do. I have gone at max of 6 in real time. Then you can roll back to the desired save point or roll back to the beginning. Simple rollback will do undo whatever query is done after begin. Or you can do commit. Uh, this end is something different, which will directly cause commit or rollback. And we saw lock and deadlocks. It's not keyword. Deadlocks. Okay. Anything here? Any questions? Fine. Rajesh, you can stop the recording.